everybody. What I had in mind for today was to give you an overview of what we have in the source code, where we have it, both the compiler source code and the Visual Studio tools and runtime source code, and give you a bit of an idea about if you want to recompile the compiler, how to do it. It's not easy, but it's possible to do it yourself. And then I want to spend most of my time on the Visual Studio integration and especially the runtime to give you guys an overview of what we have done. And well, in the case of Fox Pro, what there still has to be done, which is also important because we got some questions from people. How can we help? So I'll cover that. Let me start by sharing screen. Okay. Chris, I'm going to make you a host, so in case someone knocks on the door, you can let them in, because
Okay.
I will not be monitoring the participant list anymore from now
on. Okay.
Yeah. Let me make this smaller. You guys see my screen?
Yes.
Yeah, okay.
Yes, I can see
Good.
it.
What we have at the moment where we store our sources on GitHub, and we have two main repositories. One is called XSharp Dev, you can see it top, and the other one is called XSharp Public. The naming is probably doesn't really make sense anymore because they're both public, and before, when we started, the dev one was for the dev team and the public one was public. But since, well, the reason why we wanted to keep the source code for the compiler secret was because there was a competitor trying to get our source code. But since that company has shut down now, we decided to make everything public. But the distinction is that the XSharp/XSharp dev is the compiler, and the XSharp/XSharp public contains the source for tools and runtime. And with tools, I mean Visual Studio, but for example, also the VO exporter and some other tools. If you've worked with GitHub, you will know that GitHub contains branches. And I think some companies are changing the names of the branches because there is historically the word master has some connotation, which reminds of the times of the slaves, but we still have called it master. So the master branch is basically the branch where we store the code that's in a release. So stuff that is released is in the master branch. And apart from the master branch, we also have feature branches. And you see here that in the XSharp dev, there's actually only one feature branch. It's called feature/XSharp compiler. And that contains the current check-ins from stuff that we're working on. And that in the team at the moment, you can see that if you look at the changelog, only Nichols and Robert are doing work on the XSharp compiler branch. And every time when we do a new release, we actually migrate those changes from the XSharp compiler branch to the master branch. And inside the master branch, we tag releases. So if you see v2611, that is actually version 26a that we call it. And the one means that it's the second version, because 2610 is the official 26a, but we did a small change afterwards. So if you are interested and want to get the source for a particular version, you can scroll down here and you see, well, we did some name changes over the time, but you can see each build that we had over the last few years. So we do develop in the compiler branch, and we move things over to the master branch. Now, if you look into the structure of the repository, you will see that we have a Roslyn folder, an XSharp folder, and a tests folder. And in the top, we have some files that start with a dot, which are like GitHub specific files. And we have two command files, or actually three command files. If you download the stuff, and want to build it on your machine, you need to run continuous integration build.cmd. This also runs on the GitHub server as an action, and each time we rebuild or we check in something in the master branch, this actually starts to build the compiler on the Git machine in GitHub. Then we have an action for that. So this installs on a clean machine. The machine in GitHub has Visual Studio 2019 installed and Enterprise. So but in this command file, we set an environment variable VS version to 2019 and VS edition to Enterprise. If you want to run this locally and you do not have Enterprise, but for example, Professional, you could set the environment variable VS edition before you run the command file to the string Professional without quotes, and then run the command file, and then it will just work with the Professional version of Visual Studio. So this is how you can build it locally. Inside this folder, you see two subfolders. One is Roslyn and one is XSharp. Roslyn contains the source code that we cloned from Roslyn, and the folder structure in here is the same as the folder structure in Roslyn when we did that. Actually, this is not the current Roslyn. As you can see here, it says Roslyn 2.10. We didn't actually update to the latest Roslyn. They have changed the folder structure, which would mean that we have to also do some work. But you get the idea. Inside the source folder is, as you can imagine, the source for different subsystems. So you see compilers, editor features, but you also see setup, Visual Studio, workspaces. This is how they designed it. And in their build folder, you find stuff like specific files, for example, target files, which control how things are built. Now, if you go and look into the XSharp folder structure, you see a similar folder structure. We inherited that, and you also see a solution, which is the solution that we use to build the compiler. One important thing here is that the way they build stuff is a bit different from how it's done in, I would say, normal Visual Studio solutions. This is actually designed for running also outside of Visual Studio and do command line builds, because they also have automated command line builds. And to control, for example, where output files are written, they use files inside this build folder structure, target files, and these target files control, for example, output folders, but also versions of NuGet packages, and we kept that. So this structure that you find here is sort of copied from how Roslyn does it. And for example, in these files, you can find the .NET Runtime version that it uses, or the minimum version of Visual Studio that it wants. And these are all properties that are used in the C# projects that Roslyn consists of. Now, I'm not going to spend too much time in this source because it's quite complicated, but the important thing to remember is that there's a distinction between Roslyn and XSharp. Now, what we do inside the XSharp compiler, we actually combine both files from the Roslyn folder tree and files from the XSharp folder tree. And let me open Visual Studio to give you an idea. I haven't opened yet. The everything inside this repository is set up so it runs path independent. So you should be able to clone this repository and put it anywhere on your machine, and it should build. Originally, there were some problems with that. but especially now we have everything on the building on the GitHub machine. We know absolutely sure that there are no fixed paths in there. So this builds on any machine. Now inside the solution, you will see here a folder structure with Roslyn. It contains some tools from Roslyn that we use. I'm not going to spend too much time on that. And it contains a folder structure with the name XSharp. And inside the XSharp structure, you see a folder with the compiler, a folder with scripting, and a folder with tools. Now, the tools, the 3.1 on the bottom, the 3 tools, is actually the source code to the C# compiler. And we have included this source code into this solution, so we can be sure that whenever we touch something in the Roslyn code, it's not breaking the C# compiler. And then when we know that the C# compiler is still compiled, we at least haven't broken anything. And we made one modification to this C# compiler, and it is that it translates certain namespaces from whatever C# to whatever X#. So in our compiler, things will have an X# name and not a C# name, which is useful if you want to include the compiler as a tool in something that you create yourself. And you also want to include, let's say, the C# compiler, you would have namespaces with the same name from 2 different assemblies. Now, .NET allows that, but it is quite complicated. And by adding this automatic renaming, we make sure that even the code that we consume, which is from Roslyn, gets an X# name. So if you open one of our assemblies, you will see that the X# name is there instead of the C# name. This has one disadvantage if you want to debug, because what the compiler does, it takes the source file from disk, it does, well, Clipper guy would say a string tran, and it translates C# to X#, but that means that the source code on disk doesn't actually match the source code that was used to compile, and that means that the CRC is different. Now, if you do not set an option in Visual Studio to allow the source files to be different from the source files that they were at compile time, then the compiler will not stop if you want to debug the compiler. So this is an option if you want to play with the compiler and you want to set the properties. Debug options. So there's an option here that says require source files to exactly match. Now, this is a special version of Visual Studio where I haven't debugged the compiler yet, so this is enabled. But if you leave this on and run the build the compiler and want to debug it, it will not stop, because it tells you that the checksum that it has stored in the PDB file doesn't match the checksum of the source file on disk. And this is because of the string translation that we have done during compiling. It's not a major thing, but it's helpful. Now, what we've done is we have created with Antler a grammar definition. This grammar definition looks like this. I'm not going to explain it into detail, but this basically from top down describes what our language looks like. So we see the most important one is source. We say source consists of entities, and this builds a collection of entities, and each entity is either a class or a Fox class or an XPP class. And inside, or it's a function of procedure. And inside func you can see the rule that it says it starts with the keyword function or procedure. It has a signature, which is parameters and a return type, and it has some clauses like init1, init2, which are init procedures for procedures. These shouldn't appear with functions, but as you can see here, we still allow it for functions. So what we've done is we created a grammar that's fairly forgiving. And so we even allow you to write code that says function foo init1, which is not valid, but the parser will accept it. And later on in the compiler, we will check if the parse tree contains such an illegal combination, then we will generate, for example, an error that init is only supported for procedures. By doing that, we can create a fairly flexible parser with not too many error checks, etc. And we parse almost everything basically, and then later on we say this is not right, this is not right. And the same way you can see that, for example, the end proc or end function or is also defined here, but it is between parentheses with a question mark. So this says that it's optional. So we allow it, but it's not mandatory. And you do see that we put something like this here, T and a T2, and which we use later to say, because if you do function and the compiler matches it or the parser matches it with end procedure, then we generate an error because we didn't expect end procedure, we expected end function. But as you can see, the parser still accepts it. It doesn't care what you can start it with procedure and end with end function or vice versa. But then later on, we run a tool that basically says this combination is invalid. Now, I'm not going into detail, but you can see this is quite complicated. The result of this is a class that's generated in the generated folder. I'm not going to look into the class, but it basically will build a tree of elements that it found in the source code. And with this tree, Antler generates also something that's called a listener. And this listener we use to walk the tree basically and to say, what do we find? And then Antler generates in this listener methods that, let's look at one. For example, enter statement. So it walks the tree, and when it finds a statement, it calls the enter statement method of the listener. And when the statement is done, it calls exit statement. What we have done, we basically use this to walk the whole tree and then build a tree in a way that Roslyn expected. So we create with Antler an Antler parse tree, and we create a special, let's say, sibling tree, which is Roslyn tree. Link these two together, and then feed the Roslyn tree to the Roslyn compiler. Now, this sounds quite simple. It is not. Took us a while to get it done. And what you find in this code here, this is basically all from the XSharp folder structure in our repository. But over here you see, I'm not sure whether you can see it, but here says core and C#, and there's a link icon in there. This is basically source code from the Roslyn folder structure. So you can probably see it if you go to properties. Over here you can see that this points now to a file in the Roslyn source compiler's core folder. This is the core, and basically this one contains files that are in the Roslyn source compiler's C# folder. So in C# there are separate assemblies for what they call core and C#, and there's also an assembly for Visual Basic. What we have done is we have integrated the source code from core and the source code from C# into our compiler, which is written in C#, and we've added files that we've written ourselves. So what you see in the other folders here, you do not see the link arrow is just inside our compiler. And yeah, we've added some stuff. For example, we have added we have memory variables. So we have added a symbol type, which is basically for undeclared variables or for fields in the DBF. And we have added some extra properties to existing classes. So what you see here are extra properties or extra methods that we written and that are called from within the C# code. So over here, for example, you see a method called adjustGenerated_constructor, which is called from within the C# code, the C# compiler code, in a if-def construction. So we have this all in an if-def, so we can still compile it in a normal compiler, C# compiler, but when we compile our compiler, this gets called. What I said before about the parser and the syntax, and then I won't skip this because I think for most of you this is over your head, I realize. But what we have done is we have created a special listener, which is called the parse error analysis. And as you can see, it is inherits from XSharp base listener. And inside this special listener, so after we've parsed the source files, we're actually going to check for things. For example, let's do something. We have a while statement, and in the rule in the compiler, the end or end do keyword for the while statement is optional. But this is checking now to see whether if you've forgotten the keyword, and if you did, this is then going to throw an error saying the end do keyword is missing. And the same for end with or exit function. Like I said, if the init exit is set and it's not a procedure, then you get an error message saying init exit is only allowed for procedures. And well, there's many things here. For example, if it's an init procedure, it cannot have parameters. So if it is a procedure, but you've declared parameters, this is going to generate an error that init procedures cannot have defined parameters. Now, you can imagine that we go through all kinds of possible errors, but we do this in a separate step. So when we actually start generating the Roslyn tree, we do not have to worry about impossible things anymore, because we know we did all the checks already. So that code can also be relatively clean and doesn't have to take into account illegal combinations of options, etc. The result of what we built is 3 assemblies. Is the code analysis assembly, the XSC assembly, I didn't want to open this one, and the XS compiler assembly. Now, we've modeled this on the same model that C# does, because you see here CSC, CS compiler, C# code analysis. The XS compiler is the program that keeps on running to speed up the compiler. The XSC is the command line, and the XSharp code analysis gets used by both the compiler, XS compiler, and by XSC. Now, if you run the XSC compiler with the /shared command line option, which is the default if you run a Visual Studio, then it actually loads XS compiler and feeds the command line options to XS compiler, which keeps on running. The way this was done by the C# team, or the reason why it was done, is because reading meta information from .NET assemblies can become quite expensive. It can take some time. And by keeping this process running, it can cache the information. So the second time, for example, you compile an app that needs system Windows forms, it already has read the types and the methods inside system Windows forms, so it doesn't have to do that again. And as a result, the second time you run the compiler for the same project, then all reference assemblies will already be in the cache, and it will be much faster. So if you see that the compiler takes some time, and then the second time you run it, you should see that it's much faster. It can really save many, many seconds. So we've chosen the same model, and this then runs in memory. Now you
Sorry.
yeah?
It would interest me if you can explain this, what means keep the compiler running. I thought it is an exofiler.
Yeah, that's true. Well, XS compiler runs like a service. And this service keeps on running until a timeout appears. And the timeout is declared in, no, not here, in here. It says that it keeps on running for the number of 600 seconds, so that it keeps on running for 10 minutes, and then when nothing has happened in 10 minutes, it disappears from memory. And so XSC uses a named pipe to detect if XS compiler exe is running, and this named pipe contains information about also the current user. So if you are running on a terminal server, each user will have its own version because, well, it just has its own version. Security rights, etc., to reading folders. It doesn't want you to abuse compiler exe that has more rights to folders. So, and what we have added is that this named pipe also contains information about the case sensitivity of the compiler, because we allow you to run xsc.exe excuse me, with a command line option to say case sensitive yes or no. And this case sensitivity flag controls also the way things are stored in the cache, because we store it in either a case sensitive or case insensitive cache. So if you see two XS compiler exes running, this usually means that you have one project compiling case sensitive and the other case insensitive. And we keep then two separate exes because we want to, otherwise it's impossible to have a cache which is sometimes used case sensitively and some case insensitive. That is too complicated. So it's XSC checks for a named pipe. If it's there, it uses the named pipe and sends in the command line arguments. And then when XS compiler exe is ready, of course it produces the file or produces errors and uses the same named pipe to send the error message back into xsc.exe. Is that clear? Okay.
Yes, okay.
There was more questions about this? No? Good. In general, you don't have to worry about this. We have taken care of that. We have added, for example, we have moved one of the compiler options into XSC, so it's handled there. This is the case sensitivity. So we can change the name of the pipe, basically, to have a case sensitive and a case insensitive pipe. Most of you will never use that, but for example, inside the runtime solution, we are compiling XSharp Core, XSharp RT, etc. in case sensitive mode to make sure that we're not introducing problems for people who want to access these assemblies from C# code and having name problems in there. And by doing that, we get a bit cleaner solution, basically. Okay, I think the last one that I want to mention here is inside tools, you will see XSharp VS Parser. Now, inside Visual Studio, we are using the XSharp VS Parser assembly to tokenize the source files, which is used, for example, to set the keyword colors and to define regions, etc. And we use XSharp VS Parser to parse the source code when we want to feed your source to the Windows Forms editor, because this needs very detailed information. We need to parse expressions and somehow pass that in an object format to the Windows Forms editor. That's why we need the full parser in there. For parsing inside the source code editor, we do not use this because source code editor usually contains code that is incomplete with missing parentheses, etc. And we discovered that using the normal parser with incomplete, incorrect code gets a bit too slow, basically. So we have written a handwritten parser which has references in comments to the normal parser that says how that basically parses statements but not expressions, or very little of the expressions. Good. Any questions about the compiler? Well, I
would like
you just you look at it and play with it if you want. Yeah.
Just a question: how do the services or the compiler and the other components do communicate in Visual Studio?
Okay, good question. I'll load the Visual Studio solution in a minute, and then I'll show you. Yeah, is that good?
Yes, okay.
Okay, let me switch the phone off. Not now. So, oh, my phone is off. I should have done that before, sorry. Good. The second Visual Studio and the runtime are in the second most important repository, which is XSharp Public. Now you see that it has a bit of different structure. Actually, it doesn't follow the recommended structure that if we wanted to become a .NET Foundation project, we would probably have to follow the rules that the source goes into an SRC folder, and we have a docs folder and a build folder or something like that. We don't do that here. We are considering of making this a full .NET Foundation project, and then we probably have to move things around. But for now, you see that we have, okay, we have, I described branches before. If you look here, you see that we have a feature branch called runtime and a feature branch called IntelliSense, which should probably have been VS and tools, but we named it IntelliSense. Now, this may not be the best structure for branches, but this is something we have chosen. And what we do while building, while working on the Visual Studio or working on the runtime, is we either check our changes into the IntelliSense branch or we check changes into the runtime branch. And when we do a build for a release, we merge things into the master branch. And if you want to do something with the runtime, you can go to this folder and clone it by either downloading the zip, or you clone it into your own GitHub account, basically create your own repository, or you open it with Visual Studio. You see many options. I would recommend either downloading it as a zip or clone it in your own GitHub account information and then work from there. The advantage of, because you could clone this locally, or it's not clone, you could open it locally with Visual Studio or GitHub, but you have no write access to our repo. So you could work with it, but you couldn't check anything in remotely. By doing your own repo, which is a clone of what we have here, you can also check in things online if you want. In the folder, you see a Visual Studio folder and a runtime folder. Most of what we have for Visual Studio is obviously in this folder, and what we have in the runtime is there. Other folders that are important is the common one, which contains some, well, the name says common files like build numbers, header files. For example, common assembly info PRG contains stuff like the assembly level attributes, which control the version information. And we have, yeah, well, this one probably shouldn't be here, Vulkan console, this is wrong. But we have some other stuff like samples and tests. Most important stuff, I think, for most of you would be the runtime, but I want to spend a few minutes on the Visual Studio before we go to the runtime. In the Visual Studio branch, you will find all the components that are running in Visual Studio. And the most important ones is the project system, which is here called project package, which contains basically the support for loading things in the Solution Explorer, getting the proper icons there, and also connecting all the things together in Visual Studio. So the project system knows how to open a special editor for the VO forms, for people who work with VO forms. The project system knows how to start a debugger. The project system knows or somehow declares how to set up the language for files with PRG extension, etc. At the moment in the Visual Studio, many of the language server things are also inside project packets, and with the language servers I mean code completion, region definitions, highlighting tokens, etc. Except for the colorizing, which is in the colorizer. In the next build, this will change, and the colorizer and these language service parts from the project package will go into a separate language service DLL because we want to have two project packages to also support .NET 5 and .NET Core, which has a different project file format. So colorizer right now doesn't have much. It has mostly the colorizing of the keywords, but in the next build, the language service parts and the colorizer will go together in a XSharp language service assembly. Now, the other important tools in here are the code model. Where is it? XSharp code model. This is written in XSharp, and this contains a in-memory representation of what we find in the source code. This is responsible for scanning all your files to start up and building an in-memory representation of the projects you have and the files in there. If you start Visual Studio with an XSharp solution, you will see scanning on the bottom on the taskbar or the toolbar. This comes from this particular component. And the information in this component is used mostly for code completion in the editor and stuff like that. In one of the last builds, we have switched from keeping everything in memory into storing it into a SQLite database, and you will not be surprised that XDatabase contains the interface layer between the code model in memory and the database, which is on disk and also in memory. So this component takes care of keeping track of which files belong to which project and which types are in the file, which methods are in the file, etc. When we populate, for example, the combo boxes in the editor, we get this information from this component. Now, inside the component, you will see something that's called the Parser, XS Parser, and this is the handwritten parser that parses the entities in the buffer. And let me find for something. Over here, you can see that we have copied several parts of the ANTLER definition here, so we know we try to keep this in sync with the ANTLER definition. So, but this is all handwritten, and if you would look at parse statement, you will see that, let's say, for example, for a local statement, it parses a declaration statement, but it doesn't parse everything. It calls a read line, which basically reads to the end of line after it's found all the relevant information. So it doesn't actually parse, for example, expression statements. The only thing it does when it's not a local or a field or a member, parameters, etc., it checks if the line declares new locals. And new locals could be, for example, in a for statement, we could have introduced a new local. And that's what the editor needs for code completion. But it doesn't really go into expression statements and stuff like that. So this is the handwritten parser. Now, to answer the question from Arne about how it works together in Visual Studio, so this doesn't use the XSharp Code Analysis DLL. This is XSharp Code Analysis DLL is used at the moment in the colorizer, as you can see in the project definition. Oh no, it's called VS Parser. So it uses this VS Parser DLL to tokenize the editor buffer. And we did that because we want to support also the preprocessor in the editor, and it was just too much work to bring that over. But we created a separate assembly for this, the VS Parser. which had to do with framework versions and stuff like that. Our compiler compiles at a different framework version, or actually it compiles at .NET Standard or .NET Core, and Visual Studio 2015 doesn't support that. So we created a separate assembly against the .NET Framework 4.6, which contains the parser that is used by the Visual Studio, and it also contains the Alexa basically, which spits out the tokens. So the colorizer uses this, and there's another component in here which I haven't described, which is the code DOM provider, and this is responsible for feeding an object-oriented list of the source code to the Windows Forms editor, and this also uses this parser to actually parse the source code of your initialize component method in your Visual Studio Windows Forms, basically. I do not want to spend too much time here. There's quite a lot of code in here, and you're free to look at it and ask questions on the forums. I just want to give you an idea that where it is. It's getting dark here. I'm not sure where, oh, you don't see it, so I'll hold it for you. My screen gives so much light that my face is still visible. The runtime source, this is of course, as I said, in the runtime folder. And we try to make things obvious, so we have folder names that match the assembly names. XSharp Core is for the XSharp Core assembly, XSharp RT is for the XSharp RT assembly, etc. Macrocompiler is there. In here you also find what we call the VO SDK, which is needed for visual object compatibility. Contains the folder structure just the way it was in Vulkan, because some of us have used Vulkan and we try to keep it in the same layout. So we have source here, which has the same structure as Vulkan. And I'm not sure what's here. There's some helper stuff in there too. And inside the runtime folder, you also find VO SDK type, which is an incomplete work on the type SDK. We have some classes running there, but not everything yet. Okay. One of the things we've done, I described before that Rosalind uses common files to have common properties in the project system. So you do not have to specify the same things over and over again. We have adopted something similar for the runtime. So this runtime targets file actually declares common attributes, let me increase the font, that are used by all the runtime assemblies. So for example, we say the base output path is solution there binary. So this controls that all our output goes to a binary folder in the solution directory and not to a bin folder inside each project. And we say the intermediate output path is derived from base output path and is configuration, so that debug or release inside object, and then the assembly name. And as a result, all the object files go into this binaries folder. Now, this has the advantage that it's easy to clean your solution because you just kill the object folder and all the intermediate stuff is gone. And if you kill the binaries folder, you just only thing that's left is source code basically. And this helps a lot into cleaning stuff basically and separating source code from results. Now there's other stuff in here, like for example the target framework version, and by doing it in a shared file, in this case called XSharp targets, we have it controlled on one location and we do not have it everywhere. The disadvantage of this is that if you open the project properties for, let's say, XSharp Core in Visual Studio, what you see there is a merge of what's in this file and, let's go to XSharp Core, for example, what is in this file. Now, as you can see here, this imports the runtime target, but in Visual Studio doesn't know whether a specific compiler option was coming from the XSharp Core XS project file or this targets project file. And as a result, if you change something in the Visual Studio project properties, it may write something here which then overrules the setting that was imported from runtime targets. So what we usually do, or in this case, is not Chris, because Chris doesn't like this, is Robert, is I said should I do, and I also know Nikos does it, is we actually write these settings directly into the XSharp file and try to avoid using this Visual Studio properties dialog, because the properties dialog is simply not smart enough to see which settings were imported and which settings were actually read from this XSharp file. You still with me? Okay, good. Now inside, let's zoom this out a bit. Inside the various folders, you find the normal Visual Studio the properties folder, and this properties folder contains just the assembly info, which is different for each assembly. The rest of the assembly info, which controls the version number, etc., is imported from a shared file in this common folder. Now, inside this one, XSharp Core, you see some extra stuff, which you do not see in, for example, XSharp RT. It's too much to explain that now, but in XSharp RT, you see the most simple version, which says the title, the description, and the implicit namespace. If you don't know what implicit namespace is, don't worry. Most of you will never need it, but this is useful for third parties to declare that the compiler can find specific types, like, for example, the B browser types in a namespace that is included with this attribute. Apart from the properties folder, each of the runtime assemblies also has usually a functions folder and a types folder and folders per subsystem. In the function, now let's start with the type folder in XSharp RT. Here you find the declarations for the array type, the binary type, the code block type, etc. So this is where we store the types for stuff we added. And in the functions, you will find, as the name suggests, functions. For example, let's start with date. There will be no surprise if you find character to see the character date of the week, or character month, or con date, which takes the 3 numbers and constructs a date, or character to date. This is where we store that. Now, as you can see, we have some documentation commands in here, but we try to keep this source clean. And to be honest, we also use the trick to import some help documentation from visual objects. So what we have here for the source code documentation is includes, basically. This says when we generate documentation, which is a topic that I'll cover later, but take the source from this particular file and this XML node and merge that together with this function. But sometimes we specify parameters here, and sometimes we completely document the function here when it doesn't exist in visual objects. So this is what we have in the functions folders. Now, and in, for example, in the RT, we have an RDD folder, and this declares functions, but all these functions in this folder structure have to do with the RDD system. For example, DB function PRG has stuff like BOF function, and it has a BOF with a parameter. As you see, we added an overload for the BOF, which this doesn't exist in visual objects, but FoxPro allows you to do a BOF in an area. So this basically takes care of BOF in the area. And you will see for many functions we've added overloads. And what you also can see is that we didn't add those overloads in a FoxPro specific assembly, but in this case we've chosen that these overloads don't really hurt, and it could also be useful to visual objects or x86+ developers, and that therefore we stored those functions inside the RT assembly. Now, to go back to the assembly list, XSharp core contains everything that doesn't use X-based types. So it contains functions and types that just depend on the .NET framework. It's also compiled with XSharp core. XSharp macro compiler only depends on XSharp core, and this is, by the way, a C# assembly. It's really complicated. It's something that Nichols created. And this depends on XSharp core because we declared some interfaces inside XSharp core that the macro compiler implements or returns. Then on top of that, we have a couple of other assemblies. XSharp RT is the one that declares all our types like array and date and float and whatever, binary, currency. XSharp RDD contains the RDDs, which is a new concept for Foxborough people, but it's basically the database driver. It's short for replaceable database driver. And inside this assembly, we've implemented DBF with NTX, which is the Clipper format, but we've also implemented Advantage, we've implemented the Foxborough format, and we've implemented DBF CDX, which is Foxborough 2.6 basically, the old Foxborough format without the special Foxborough types like integer or currency. The XSharp VFP assembly contains Visual Foxborough specific functions. The XSharp VO assembly contains Visual Object specific functions, and as you probably guess, the XPP contains XSharp or XBase++ functions. And what we try to do is when we need to add something for a dialect, when we think it is useful to other dialects, we store it in either XSharp core when it just doesn't depend on anything but the .NET framework, or we store it in XSharp RT. But where we see potential compatibility problems, or where we think something is so specific to visual objects, no XBase++ or Visual Foxborough developer will ever use it, then we store it in the VO or the XPP or the VFP assemblies.
Sorry, one question.
Yeah.
I wonder why there are so many similar parts for VO-oriented and Foxborough. I would expect it would everything should be different, and there are these many RT and core functions.
Well, we all started with DBase. Even the Foxborough people, maybe some of them didn't work with DBase, but functions like left and right, substring, the date type with the date manipulation with character to date, date to character, this is all common that we all had. And we had that in Clipper, we had it in DBase. So that's part in there. All the languages started with DBase and had the concept of reading DBFs and having a work area. In Foxborough they call it cursor, but it's the same. It's an area which is your interface between your program and the DBF. So this is common, and that's why we could store that in common assemblies. And now, if you look at visual objects, for example, they've added some stuff like the Olay auto object. This is specific visual objects. That's why we store that in XSharp VO. In XSharp or in Foxborough, they have something which is called an empty object or a custom object, which you would never have in visual objects. That's why we store that in the Visual Foxborough. But when it's common, we store it just in a common assembly because it's useful. Let's take, for example, the Visual Foxborough DBF driver. We added support for integer type, currency type. Now, and for us, it was by far the easiest to say, put that in the same assembly as the rest of the RDDs. Because now someone using the VO dialect can also use this RDD and access the Visual Foxborough table with these extended Visual Foxborough types. And I know that in VO and in Vulkan, people had used for support for that. Now, it's now there. We've added it. And so we try to put things that basically that do not bite, that do not conflict with each other, put them in the same common assemblies. just to keep it available for everybody. And I think that makes sense. And, but if we see a potential problem, then we split it out, which also means that it is possible that we move things over. We are now at XSharp 2.6, but it could be possible that we detect that there's something in Foxflow that's so different from what we have in RT that we may move something out of RT into, for example, VO, or because of the conflicts between how a function is implemented. Right now, it almost never happens, except, for example, in the Visual Fox Pro, there are some overloads for functions that have the same name but different parameters as the same function in RT. This poses a potential problem for us, but what we have done is we have basically learned the compiler that if something is in the Foxtrot VFP assembly and also in, let's say, RT, that the function in VFP gets preference over RT. So that's the trick we taught our compiler, so you will not be bothered with this. And also, if the same function is in RT and in core, it will say the one in RT gets preference over the one in core. So we make some decisions there, and the compiler just doesn't show you that. If you would link the same two assemblies in C#, it would actually start to complain that it finds, or actually not really, because it doesn't know the concept of a function, but in theory it could complain. It will complain if you do it using static in C# for XSharp core functions and XSharp RT functions, because then it may find the same function name in both assemblies and will say, I have no idea which one to call. We take care of that at the compiler level. This is one of the changes that we made in the code from Roslyn, how to resolve methods, for example. And we've also made changes in how to resolve, for example, when there's a left function, which is in our assemblies, and you add a left method to your class. In Visual Objects, the left method, you would never have call left method directly, because you would always prefer it with prefixes with either O something colon or self colon. And so left without any prefix would always be the function call. And we have to change the compiler to give preference to the function call over the method, basically. Because we do support calling methods without self prefix, which is new. And in that case, where there's no function with that name, it'll call the method. But if there's a function, we have to make sure that the function gets called over the method when it's not prefixed with self, or this in Foxtrot dialect. So if you use the code the old way with self colon prefix or with the this dot prefix, you have no problem, because then the compiler knows that the scope where it needs to look for left is the class and not a global function, basically. Well, if you look, one of the reasons why we do this is because people in the Foxtrot community ask, okay, where do we start? How do we do it? Now, I would recommend to download or clone this repository. You can either download it as a zip, or you create your own clone repo and put it there. And then just code. Check your stuff in, create samples, and see if you can get something to run. Now, how do you know what we didn't implement? Well, some of it is because we have in the Foxtrot assembly to do A, to do B, which basically are functions that are not implemented, and the B ones start with a B. So we have bin to C, for example. And actually, as you can see, we have a comment in there that says to do, which means that this is compiled. It goes into the help file as well, but it has a to do command in the help file. So that way we see that it's working. And it can probably show you that. Let's see. We have the runtime help. Oh, come on. Here, what was the function? Bin to C. There it is. And you can see the bin2c function is in the documentation. And for some reason, it didn't pick up the comments, but you can see it's in here. It's doing nothing.
Robert,
Yeah.
This Matt. Hey, I was going to ask or throw out one comment here. As I was using that help file before, just sort of looking around, it seems like there's a divide where the FoxPro specific function and runtime things are listed here, but yet to the extent that any of these functions have been generalized maybe back down into XSharp core or something, that they don't appear, it seems, in this list. Is that correct?
Yeah, that's true. Okay.
Is there any way to maybe, you know, so that the list of functions itself would appear complete and people don't have to think, oh, well, let me go look and hunt through here, and no, I don't see it. Well, now let me go look and hunt through over here and see if I can find it there. Is there any way you could think of that would?
Yeah, it's a bit complicated, but first of all, if you use the help file and you use a day2character, for example, you will see one day2character function, and it's just there. So it doesn't. You don't have to specify the FoxPro function or the core function. So if you use the index, you will always find it. So that's one thing that should help you. Let's see.
Does that same type of searching also work presently through the runtime? Is that where we're looking here, like in the website?
Yeah, in the website, if you look here and you do DTOC, in the top right corner, let me use the font, day2character.
Right, I'm tracking with you.
It gives you that, and then it just jumps to the right page. Now, as you can see here, it is in the namespace XSharp RT. So this is where, and you see the assembly where it is. You can see that this help was generated from version 2.6. And we see a couple of C alsos. And if you click on view source in the web browser, it actually is going to jump to the right source code line.
Show me again where you found that view source link again.
Over here.
Oh, I see it. Yeah, okay.
And in the help file, the button is there too. But if you do it in the help file, it doesn't jump to the right line. And well, it appears that if you have a link with a bookmark in which this is, because if you look over where you can't see it, but if you hover your mouse over it, you will see a link that ends with hashtag L65, which is line 65, but somehow the XML help or the HTML help swallows that bookmark and doesn't jump there, and I cannot control that. That's something, a restriction to the HTML or the CHM format, basically. So yeah, that's what you would like, what I understand, and this is just work, and this work that someone could help with too. What you would like here is a list of functions, basically, which there is not now. So over here, you see XSharp core functions, XSharp RT functions, XSharp VO functions, etc. VFP functions. Let me explain why this is, but I'm going to switch the light on here. 1 second. It's getting too dark. I can hardly read my own keyboard. When we compile code in .NET, .NET doesn't know the concept of a function. So we needed to find a solution for that. Now, we didn't want to reinvent the wheel, so we looked at how Visual Basic does that and how other languages do it. And what all languages do is change, or they implement the concept of a function, but they change it to a static method, so a method that doesn't require self in front of it or a object dot or object colon in front of it, just the method name inside a class that's compiler generated. We do the same. So whenever you declare a function or a procedure, but also a global, which is something in visual objects, or a constant like a define, I don't mean hash define, but a normal define. These are global things, basically, global fields or global constants or static functions. And they all go into a functions class. Now, every of our assemblies that contains functions has its own functions class. And what we have done, we've told the compiler to give these classes, the functions classes, a namespace. So inside XSharp core, the functions class is in the XSharp core namespace. And this contains all the functions that are declared in XSharp core. Now, to generate the documentation, we are using a tool called Sandcastle, which is a free tool that you could download. And this tool will produce a help file that says XSharp core functions class, and then list methods in this function class, and prefix the methods with this S, which means static. And it says, if you hover over it, you see static member. So this is a static member of the functions class. Now, what we have done, if we have written a plugin for Sandcastle to modify the generated HTML pages and to add, instead of saying functions class, we say functions, globals, and defines, because this contains the functions, the globals, and defines. And some of these are globals, some of these are defines. You cannot see it over here, maybe, but if you click on them, this is, for example, this is a define. We could detect it because it was had a constant property on it. And what we also do is we generate the page for eRetry define, which originally had something like the field eRetry in the functions class, and we generate eRetry define, retry define. And for example, for a function, this used to be functions.addReal8 method, and we changed the generated documentation to read a addReal8 function. However, because these functions classes are in different namespaces, the tool generates for each namespace its own functions class. And there's no easy way at the moment to merge that. So that's why you see multiple entries here. What we could do is we could add handwritten a page that says all functions that are data related, all string related functions, or all array related functions, and then put links in there to the implementations regardless of where they are, and then group them together. We haven't done it yet because that's simply a lot of work. But yeah, that would make things easier to find. I absolutely realize that. I think we are already quite happy that we were able to, in the documentation, give things the name that you expect. So a copy, to copy an array, is called a copy function. And actually we also added a syntax element to Sandcastle, so it produces function a copy, a source as usual. And in C# you will see the C# syntax. So what we have done is we have created a syntax component, so this looks familiar. So that's why you see XSharp here. This, of course, this tool doesn't know XSharp. Who knows XSharp on the world, except for the people from the XBase community. So we've made some change there to make this possible. Now, what you do see here is that everything here is declared as usual. If you look at the runtime source code, let's go back to the source code. XSharp RT, and then types, because usual is a type. Well, it was no surprise that usual is a PRG name, but now you see that it's actually not named usual. So the compiler knows that whenever something is declared as usual, or when you do not declare anything at all, no type at all, that it needs to map it to the __ usual type in the XSharp namespace. Now the help file doesn't say that. So one of the things we also do when we process this documentation from Sandcastle is that we do a search and replace and make it __ usual gets replaced with usual. So it looks better. So we have done already quite a lot. And if you go to usual, you will see that it actually jumps to usual structure. Now, and those of you who look really careful see that for some reason the alphabetical sorting is strange here, and that usual, well, I say the D from DB data column should probably appear between date and float. It doesn't, because the original sorting was based on __ D and __ F, and these all appear before the D. So that's why they're also in a different order. So what we do is we take this Sandcastle stuff and we have added some plugins that make adjustments to the documentation so it looks nice, and we also added the plugin that allows Sandcastle to generate syntax in XSpace format, basically. You can use if you like that, you can use this tool as well. And if you want to document stuff in XSharp syntax, the components for that are all in our repository. Like I said before, we have a tools folder. And if you look in the tools folder, there's a SHFB, this is Sandcastle help file builder. And you will find a plugin, a syntax, and a VS. This contains the presentation style, because we made a few changes to the presentation style. This contains the component that generates the XSharp style syntax on the topics pages. And the plugin is actually a tool that, well, it says over here, it post-processes the generated pages, and it generates methods into function and the types, etc. So if you want to use this, feel free to use it. We use it, and if you have, that's for everything what I'm showing today. If you think of a better way to do things, or a faster way to do things, or you want to implement new stuff, please let us know, or write it and send in the contribution. So I got distracted by Matt, which is good because this was supposed to be interactive. Like I said, the files in here with to do contain stuff that's not implemented. And in the help file, what was it, bin to do? Is actually, well, this should have contained information. There's a problem apparently in the code generation, but here, for example, in the bit end, you will actually see the to do command. And if you look at the functions class here, you will also see for the topics that have this summary to do, they are listed here as to do. Also, some things are listed as obsolete. Now, there may be stuff in here that the Foxtrot people say, no way, this is not obsolete, we actually really need this. Let me know, and I'll change it into not implemented, because apparently I have not implemented it yet, and then we can go and implement. But in this functions class inside VFP, you will find all the stuff that didn't exist yet in the other dialects, or stuff that is actually implemented differently. And as you can see, bit end is not implemented. What you do see is a lot of documentation already. There is a GitHub page with Foxpro documentation, and we have taken the liberty to write an XML parser and parse this documentation and bring it in here. Not everything was properly formatted, and so one of my sons has actually worked a lot to create proper tables for stuff that was a table, etc. Not everything may be perfect yet, but most of the stuff should be fairly complete, except that the function is not implemented yet. So that's something we need to do. Now, let's assume a binary is not in the B, because I think I created the bit functions here, but these are also not implemented yet. Let's assume you want to start implementing bit end. Well, the best way to do is to just check out the code or download the zip and start implementing it. Create a test sample and make sure that we produce the same results as in Visual Fox Pro. And then what? Well, then there are two options, or actually three options. But there are two options that I prefer. One is you close the repository and you have your own version of the XSharp dev public repository. Then, of course, you commit and upload your changes to your repository. And then from your repository, you do what's called a pull request. And a pull request, if you don't know what it is, look it up. There's videos on the web how to do it. But a pull request basically generates a request to the repository that you've cloned and says, okay, I have changed some source code. Please review these changes and include them in the main repository. That's the normal way to do things on .NET. So you ask the maintainer of the main repository to integrate your changes. That's what we prefer. The other solution is you download the zip and you have no repository. You zip up the changes and mail them to us. The third version that I've seen a lot done by Foxpro developers is put the stuff on the forum and start a thread and add it as an attachment. It works, but it doesn't have my preference because I have to go and look for stuff that was posted there, and I may overlook things, especially if the thread is busy and especially if it's in the public forum. I'm not always monitoring the public forum. We try to do our best there. Chris is also not always monitoring, but then we could miss contributions. So if you want to make sure that it's included, either clone the repo and do a pull request, because there's no way I can miss that, or you zip it up and you mail it to us. And we would please ask you guys to introduce also test code, unit tests, so we can make sure that the stuff will keep on working the way it was designed. To give you an idea about what we do with unit tests, let me open the Visual Studio solution for our runtime. Okay, and this looks terrible because I have large font, so you can read it at home. No, not that one. That one. One of the things you can do with Visual Studio or with GitHub, which is not was not obvious for everybody, is that you can clone a repository more than one time. That's what I have done. I have two clones of the XSharp public repository, and one is checked out in the feature runtime, as you can see on the bottom right here, and the other is checked out in feature Visual Studio integration. And that way I can make changes to both branches without having to switch between one branch and the other. And this is especially useful in our team where, for example, Fabrice almost never touches the runtime, but he works in the Visual Studio, and Chris doesn't touch, or usually doesn't touch Visual Studio, but makes changes to the runtime. And by doing that, we do not have to merge everything from one to the other branch. You can just keep changes separately. Anyway, why I wanted to go here is for the unit tests. You may have seen the folders already. Let's close this. But we have actually created unit test projects for most of our assemblies. You do not see a XSharp RT test. That's because the RT tests are part of the VO tests historically. But let's start, for example, with the core test. And as you can see now, we actually have created source code for small tests, and we're using the XUnit unit test framework. We could have used Microsoft Test or NUnit. The reason we've chosen for XUnit is because this was also used by the Roslyn team, and XUnit also runs on non-Windows platforms, where Microsoft Test runs on Windows platforms only. And this way we can make sure that if we wanted, we could run our unit tests on non-Windows as well. And what we do is write small tests. We put traits on there. In fact, these are the attributes that the XUnit uses. And then in the Visual Studio, you can open the Test Explorer window. Where is it? I don't see it. Probably because my layout is wrong. Ah, there it is. And this will, this Test Explorer will look at all the output files from all the projects and find unit tests in there. So we saw a byte test, and in here you see there's a swap byte test, which was the code we saw before, and there's a swap word test, which was here, and this actually points to these methods. Now, and inside this text explorer, you can then debug a simple test. So let's assume that I want to debug swap byte. We can debug it from here, and then it should stop there, hopefully, or you can just run everything. Now, as you see, it does indeed stop there, and this is the function that we wanted to test, and we can step in there, and we can see the function. Now we can see that it actually does a left shift and does a right shift, and that way it swaps things. How exactly this works, I have no idea. Well, actually, I do, to be honest. But this basically works. And if the result is not what we expect, then this should return an exception, which is what assert equal does. So by creating small unit tests, you can be sure that if the code runs, we will not break it. And we have tried to create lots of unit tests. You would probably think only 423, but most of the unit tests contain multiple tests, which is probably not the way the test gods wanted, but it was simply convenient for us to combine multiple tests. And you will see that over here we have, let's say, half a dozen or sometimes even more tests in one of these test methods, basically. Okay, so if you want to contribute, check out something, write tests, and you do not have to use unit tests, but at least write test code. We prefer if you do unit tests because then we can just copy and paste it over. But if you write test code, then we'll probably take your test code and convert it into a method so we can integrate it in our test suite and make sure that things keep on working the way they were designed to work. For those of you who work with C#, C# has the mechanism to run, let's say, where is it? there's an option here. I'm not so sure where it is to continuously run tests. We do not do that. We do not support that because that requires some support of the project system, which we do not have. So what we do is we run the tests either here or we run them from the command line. But over here we can run all tests. And actually this also allows you to do code coverage and see how much of the code that you've written is being tested by these tests. I'm sure that you will find that the code coverage is not optimal yet. I know we need many more tests to have 100% code coverage, but at least we've tried to cover most of the edge cases, let's say check for minus or positive differences, and zero and max of a max keyword or max word or max long. But I'm sure we have missed some ifs or else branches. It's not perfect, but for us, it seems to work. And by having these tests, we try to avoid reintroducing old problems in new builds.
Hey, Robert, I know you asked earlier not to use the chat panel, but just to throw this out, I pasted a link in there. I know you'll remember this, but the years ago when .NET was first coming out, people in C# wrote many of the runtime FoxPro functions. They wrote, a class with a method on them, and I pasted a link to it in the chat panel over there.
I know.
So
it's useful for others too. I agree. What the problem with that is that I think you suggested that on our forums too, and someone else replied, "Oh, but these functions do not do exactly what to do in FoxPro, so they're useless." And then I have no idea what to do. Do I?
Yeah, I wasn't necessarily suggesting that we just wholesale go with this, but in case anybody wanted to see a C# implementation of what was done in FoxPro, it's at least an example of a way that it was approached in C#, and from that, somebody could look at it and say, okay, I see what they're doing here. I mean, there might be some cases where it's perfectly fine to use, and some places it just gives you an idea of what to do or convert.
I agree, it's useful, absolutely. For example, it has code like the get caller dialog, which uses a standard dialog from the Windows Forms hierarchy to open the caller dialog. I'm sure that this could probably be copied over and used as well.
It's just a
choose
general
file or whatever, get there. We can probably take that over and with minimal changes implement that.
Yes.
I haven't found the time to do that yet.
No, I agree. And it's just, I just wanted to throw it out as something that's there. I'm not blindly saying every one of these is a perfect way or implementation, but it's just a little breadcrumb of some idea here and there that some people might find helpful.
Absolutely, I agree. That's certainly helpful. For us from the XSharp dev team, the biggest problem is that we do not know exactly what FoxPro does. I'll give you one example. One of your colleagues, I think Antonio is online, I think, or he was online. I'm not sure if he's still there.
Yes,
Antonio reported this week that binaries in FoxPro can have zero length, basically. So it just can have a literal zero H, which is a zero length binary. To me, that didn't make sense. So I originally in the compiler, I told it to make sure that the numbers, the hex numbers after the OH should be a multiple of 2 and it should not be zero length. Well, apparently zero length is allowed. Someone needs to educate us there. And I tested it, of course, in FoxPro. And it says, yeah, it works. The funny thing is, FoxPro even allows an odd number of digits. So I can do 0H1, and FoxPro interprets that as 0H01. Now, I'm not going to implement that because I think that's prone for mistakes. I think if you want to have 01 as a byte, you just specify 01 and not just 1, because There could also be a number missing. Like I say, you could accidentally have to delete the number in your source code. So I think it's better to do it with an even number of characters. But apart from that, yeah, you guys need to tell us what to do, and we implement it. And by the way, Antonio, I've also implemented the support in the usual class for binaries. So the casting that I suggested on the news or on the forum is no longer necessary. As you can see here, this is the nice thing of having stuff on the source code control is I can just simply compare, and you can see here I made some changes. Well, actually I changed underscore binary to binary now. I won't bother you why it originally was underscore, but it had to do with, of course, the order of in which things were implemented. And now there must be something that, yeah, this one I added an implicit operator that says if I have a usual and I'm assigning it to a binary. For those of you who don't know .NET, the compiler will look if you assign something from type A to type B, if type A has an implicit operator or type B has an implicit operator that converts from A to B. And in this case, I have type A, which is usual, and I'm assigning it to type B, which is binary. And if it finds this implicit operator, it actually will convert it. So it will return you something that's a binary. And what I've done, I'm not sure, but I think Foxcode allows that too. So when this untyped variable contains a binary, I'm obviously returning the binary. When the untyped variable contains a string, I'm returning a string value. And as you see here, I'm casting it to a binary. Now, there is no implicit cast for string to binary. However, the binary type declares, what is it? Implicit. Oh, actually, the other one. Implicit from string to binary. So the code in the usual class then triggers this code, which does runtime state win encoding get bytes and gets the bytes that are in the string and produces a binary object basically. And the binary type is implemented as a structure. For those who are interested in that, probably easier to go to the top. And the structure only has one element, which is an array of bytes. So we are using a managed array of bytes, and we store the binary value, which is just 0, 1, whatever numbers, into an array of bytes. And we have implemented stuff like adding the bytes, deleting the equals operator, greater than operator, etc. We've implemented all the operators, and this is how it's done in .NET. So if you do a greater than, actually what we do here is we are calling a method in the runtime, which does a string comparison between the byte array on the left-hand side and the byte array on the right-hand side with the minimum number of the length, basically. And well, depends if the result is greater than 0, then the right side is larger. If this is less than 0, the left side is larger. And if they're equal, then we check if the length is different, because then we say the one, if the left side is longer, then it's greater than, otherwise the right. Well, you can read the code. So this is what we basically written to implement the binary type. All our types are implemented in a similar way. So we declare operators, we declare which kind of implicit conversions are possible, equals operator, etc. And none of the nice thing about .NET is that we didn't have to do much in the compiler. The only thing we have to do in the compiler is recognize the binary literal, translate keyword binary, which of course Foxtrot didn't have because everything is untyped. But we allow you to declare something as binary. We have to implement the keyword and map it on top of a type, XSharp __binary. And the .NET the C# compiler basically that we use in our compiler already knows that if you do a plus operator and the class implements a operator method with the name plus, well, actually it's, I think under the hood is called add, then it says, okay, I know how to do a plus operator because this type implements the plus operator. This is really cool. And even if you mix types, it knows how to look for implicit converters, etc. And the great thing about, I think, the good choice we made in the beginning is to inherit the compiler, basically inherit a lot of functionality from the Roslyn C# compiler, is that all this stuff, all the complicated stuff that was written for us by the geniuses at Microsoft. So all we had to do was implement XBase on top of it. And as you can see, most of these things are relatively easy. It's not super easy, and you have to think about when you implement a larger than operator, how do you do it? But once we have implemented a string comparison routine in the runtime, we could reuse that all over and again for everything that wants to do string compares, basically. Any other questions?
Robert, if I may.
Yeah.
Okay. I would like to second Matt's suggestion to look at BFP toolkit.net before starting any conversion or suggestion, because that stuff is really useful, and probably it just needs some easy tweaking to for instance, implement a new parameter or something like that.
Okay.
So it's better to first step, as Matt suggested, to have a look at the BFP toolkit.net.
That's good. I will. We will do that. For me, for myself.
Yeah.
But to give you an idea about priorities, because people always also ask for roadmaps and priorities. The first thing I'm working on at this moment, which I do want to finish before doing that, is the full DBC support.
Okay.
Database container support. So at the moment, we are reading, when we detect that a Foxtrot file has a link back to a database container, we're actually opening the database container to read the long file names, like long field names, like company name in the Northwind database, which is company num without the E in the DBF header. But it's not really properly implemented yet. It's like a clutch the way it's done now. What I want to do is implement proper database container, so that these database container files stay open, just like you do in FoxPro when you set database, I think you set database tool command or open database, that these things are open, and that right now it's also not optimal speed-wise. If you have a very large DBC, it may take a while before it's found all the columns, because this code is not using the index. I want to switch that and use that and implement get, I think it's db get property and db set property. And after that's working, I think we can go back to these kind of things. But the database support must properly work. And so that's, for me, I'm already working with that, and that has a priority. But after that, I think it's good to bring those functions over, and you guys can then start testing them. But if you want to already start converting, that would be great, because the more people work on it, the faster it's ready.
Okay.
And we do have more FoxPro subscribers than we had last year. Actually, we had one of the FoxPro customers has taken a company sponsorship, and we have some other FoxPro people coming on board. So for us, it also makes more sense to work on this. It's just like, but the more hands, the faster things will go. And I don't think porting this code over is rocket science. You can read it in C#, and most of it you can write in XSharp too. It's just a question of the order of the type is not at the start of the line, but it's at the end of the line with an S and then the logo in front of it. But the rest is relatively the same. So, and if you use ILSpy, not the latest version, but if you use ILSpy 5, you can download our plugin and even use ILSpy to already decompile the source code into XSharp format. It's not perfect, but it helps you to get started.
The second remark I would like to put forward is the place where we put some functions. For instance, you mentioned you'd prefer to read it in as a pull request instead of read it or monitoring on the forum. The reason, because probably most of us will be more comfortable to put it in the forum, is because we are not only suggesting to you, but also suggesting for the whole community of FoxPro. So
I agree that it's good to discuss it on the forum.
Yes.
But when
Okay.
do I know that the discussion is finished and that the code is ready?
Okay, in that case, probably the people making the final suggestion or curating the final suggestion probably should put it as a pull request for you to know. Okay,
or send me the zip or the PRG,
okay.
because
Okay.
then otherwise I'll bring it over, and then that happened before. And then the next week someone made a change, and I said,
Yeah.
oh, I have to do because I do not always 100% include it unchanged, because we also have some kind of internal standard. And for example, helper functions I want to make internal, basically.
Okay.
So do not put too many helper functions as public functions, otherwise people will get lost. So I don't want to put all those helper functions public. And that's why sometimes I've, for example, in this get word handler, someone wrote that. I think it was Karl-Heinz. I've made classes internal, and I've done some, not much, but I've done some changes, or when there was a case statement that said this should really be a switch because that's much faster. And we want the runtime to be as fast as possible. So then I go in and make some changes. Not many, but I try, because I do not want to spend too much time. But then if the next week a new version comes, I have to do it again. And that's, well, I didn't really like that.
Okay.
But I do not, for example, I would never do a comment with a star. I know that's FoxPro, but I'm used to doing // Now this now uses a mixture. I'm not going to change everything, but so I leave it as much as possible, and so that Karl-Heinz or whoever else wrote this code will still recognize his own code. But I do want to make sure that stuff is properly, not too many public things, and keep the public interface limited. So you can change things without breaking things from people. As soon as you make things public, people will use it and will start depending on it. And if you change the implementation, then this will cause problems. So that's why I sometimes go in and make some of these changes. But okay, it's good to discuss it on the forum, as long as you guys then say, okay, Chris, Robert, we're done discussing. This is the thing. Here's the zip. Please include it.
Okay, fair enough.
Yeah, that's
okay.
That's helpful, because I do read the discussions, but I really have no opinion about what, or not always about what the best solution, because I don't always know how things work in FoxPro. I have an idea and I can read the documentation, but sometimes the documentation is not correct, or it doesn't include all the possible options. Anyone else? No? Okay. Was this useful to some? I hope. if you want to debug your applications, and you have a subscriber version of XSharp, let's go, and you go to the program files x86 XSharp folder debug, you will find of all the runtime assemblies versions that are compiled with debug information, and they come with a PDB file. Now, I would recommend in those cases where you see a problem and you don't know what's happening, copy these files into your app's output folder, and these files with their PDBs should link to the source files on the folder structure that was on the machine where they were developed, which is XSharp RT for the runtime assemblies. However, by default, if you install the runtime in the global assembly cache, so in the GAC, this will not be called, because the .NET will give preference to assemblies in the GAC over assemblies that are not in the GAC. So in that case, you have to remove them from the GAC, otherwise these assemblies will not be loaded. But if you remove them from the GAC, you can load these, and then you should be able to get the full call stack for problems, and you should be able to see the source code line where the problem comes from. And if you want to do that, then you need to check out the proper master branch. Let's say you want to do something in the runtime for version 2.6a. You go to this particular tag, and this tag contains the line numbers exactly as they were when the runtime assemblies were built. And if you choose a later, so you choose the master branch or you choose a feature branch, the line numbers may be off because there could be new lines in front of the line where the problem happened. So by choosing the right tag here, you can actually get the right version of the runtime that matches the debug symbols in the PDB file. Now, one thing that I'm looking into is, how do I say it? Roslyn allows you to include the full source code of the source file into the PDB. And one thing I'm looking into, if in one of the next builds for the PDBs in the debug folder, I can include the source file in there. So you don't even have to go to GitHub, but the source will be included. So if you look in your call stack, it can extract the source from the PDB file. So you're 100% guaranteed to have the right version of the source. I'm not sure if people are interested in that, but if there's some interest in that, I will probably do that. If nobody wants that, then I won't bother spending time on that. So,
I think it's good. I think it's good.
Yeah. Okay. Chris wants it. Okay. And then no one else needs to vote. I think then we'll have it. This is also something that we do not have to invent ourselves. That's a good thing. It's part of the Roslyn compiler, basically. I need to somehow set up a special command line to tell the compiler to bind the source into the PDB, and that's it. And of course, I have to figure out how to do it, but apart from that, then it should work. And either, I'm not 100% sure, either it puts the link into the commit from GitHub in there, or it puts the source in there. I'm not sure, this one of both. I hope it puts the GitHub commit in there, because in that case, your PDBs won't get as big. But anyway, I know it works. I've seen it work. But it requires some study, because I haven't done it yet, but I just know that it works. Any other questions? With regard to the documentation that you guys have, I showed a help file. Most of what's in or actually everything that's in XSharp runtime and VO SDK reference is generated. And all the other topics are handwritten. So if you missed something there, it's simply because we haven't found the time to write it yet. We have started, for example, on using XSharp in Visual Studio. People have asked for it, but there are chapters here that are empty. And this is, again, the choice. We have a small team, and we can write Fox Pro implementation of runtime functions, or we can write documentation. And I'm not sure how it is for you guys, but if I'm given the choice, I'd rather write the implementation of the functions and then put some inline comments in there to get the help file updated. But to also start writing help pages here, it's not my favorite thing to do. So we are doing this, but it's not our favorite subject. So that's why some of these pages here are blank. I had some help from family members. That's why a lot hasn't been implemented already. And that's why, for example, you find all these help pages, because this was either copied from the C# help, because there's a C# 0019 error 2. And we've copied it over. Of course, the original samples were in C#, and we haven't actually rewritten those in XSharp yet. That's why these are empty. And some of these were also not documented in C#. That's fine. Like this one, for example, you cannot find a CS0031 help for C#. But what we've done is we've taken the resource from the compiler, and we've extracted the string here, so at least you see what message gets generated. So the compiler will, of course, at runtime, so at compile time, I should say, convert this parameter and this parameter, and it could, for example, be constant value ABC cannot be converted to an int, something like that. But we try to make it as complete as possible. But as you can see, also the C# guys do not have all the errors fully documented. Maybe they have now, but when we started writing this, they didn't have that. So yeah, we can use help with that too. If you're interested, let me know. We're using a tool called Helper Menu to write it, and yeah, we're interested in that. Also, at the Fox conference last week, or 2 weeks ago, during Eric's session, he mentioned that there were some Fox templates missing or not complete. Everything has to be written. So the Fox templates are also in this repository. In the Visual Studio repository, there are templates. So if someone says, oh, I have an afternoon and I want to do something, and by the way, your Fox Pro class library template isn't looking right, here's a templates folder, here's a projects folder, here are class libraries, and there's a class library Fox. And I know, that's what Eric told me, is that this class actually uses the core class syntax and not the define class syntax from Fox. And I said, yeah, you're right. What we did is we copied the core, and we made sure that the project file is in Fox Pro dialect, but we have forgotten to change the class 1 PRG to the Fox Pro syntax. Now, if you want to do something like that, that will be helpful too, and to others starting with Fox Pro. So there's a lot that you guys help us with, and this contains the image, which you of course can, that we take in a class library image, and we load the Fox Pro icon on top of it. I'm not sure whether Microsoft likes that, but we've taken the liberty to do it anyway. If you want to add class libraries, templates, or other templates, go ahead and please send them to us. The more we get, the better. The same for icon templates. We have code icons, and there's a class here, which is, as you already expect, probably the core class syntax. Now, it would be nice to have a Fox Pro defined class in there too. It's just work that someone needs to do. And you can copy this folder over and create a new folder called Fox class. You create this. This is not real code. This is pseudocode because these dollar names will be replaced with data when the class template is running. But you can get the idea, and then the template has to have a unique name. So this could be XSharp.Fox class for the Fox class, and then the rest can probably be taken over and used. So we really can use your help here. Some of these things are easy and are 10 minutes work. Maybe no one cares about it, and I can spend the 10 minutes and not work on database properties, for example. But if you guys think it's worth doing, then please help us and fill in these things, and then the project can become more and more complete. So yeah, we really can use your help for these kind of things. And if you want to understand how things work, I'm happy to explain that. Just start a thread on the forum. I'm happy to explain how the mechanisms behind this works, so you can get started with these things too. So we really can use some help here, and just let us know if you have time and want to do something. I think we're already half an hour late. I still see people on board, so it's apparently not too boring. But I think it's time to wrap it up for today. It's getting dinner time over here, and I'm starting to get a bit hungry too. So if you guys have any other questions, ask them now, or otherwise I want to end this session. No other questions? Good.
Thank you very much.
You're welcome. Not everything
Thank you,
will be
Robert.
useful, I know, but I hope you find some of it interesting, and you have some ideas. And any other questions, use the forum, and we will be happy to help you with that.